Alright, in this video we're going to put our draw scaling system into action.
Okay.
So before we get jumping into code here, I do want to change our screen resolution back to its internal setting. We changed this just to demonstrate the problem we had with screen positioning.
You gonna set it back to that really funky resolution that just makes the most of our recording size?
Right, our lovely 908 by 681.
It's like the most bizarre resolution ever.
But with that in place now, again, just putting this back to the way it should be, and then we can, well, write our draw scaling system and mess with it some more.
Okay.
So that should be fun. Alright, now to address the draw scaling system itself. In the last video we covered how we are going to have an internal screen, which is actually going to be a render target, and that screen is going to have a fixed size. Now let's define that fixed size over here inside of global state. At the very top of the global state class, let's add in a couple of fields. Let's make some public constant integer fields called fixed drawing width and fixed drawing height. We'll set fixed drawing width equal to 1280, and then we can just duplicate this line to make a field called fixed drawing height and set that to 960.
Okay, so that'll be that internal resolution.
So now that we have this stored, now we can go ahead and take a look at setting up that internal drawing system. So what we'll do is we'll go over here to our game class, and we'll begin with a few fields. So we'll scroll all the way back up to the top of our game class, right below the sprite batch, and we will put in two fields. The first field is going to be a render target 2D. And we will call this render target draw buffer. And so this makes our internal not displayed version of the screen. So this render target 2D is actually a place which we can render to using things like graphics devices and sprite batch calls. Now, to go along with this render target, we are also going to create our own depth stencil buffer. And the reason here is just to make sure that our render target is fully fortified with any auxiliary systems that might need or might be needed by the hardware to draw anything we would need to. That way we're not restricting ourselves to what we can draw with our various calls to sprite batch. So we're going to make a depth stencil buffer field, and we'll call this draw depth buffer.
So you're saying this is just kind of like a requirement?
Exactly. In our case, since everything has been kind of encapsulated and shadowed inside of the sprite batch system, we haven't really focused too much on draw ordering as we have been drawing our sprites.
Okay.
And there's a handful of things that the graphics hardware can do with a depth buffer and with a stencil buffer that'll allow various sorting aspects, various effects that can be done.
Okay.
And so we're going to set up just such a buffer so the graphics hardware can do whatever it needs to do, but we're just making sure that one is in place and ready to go. So now that we have these fields, the next thing we'll do is we'll go down to load content and set both of these up. So down here inside of below initialize, we have load content. Now right after we got the initial presentation parameters, if you remember, we were using presentation parameters to get the current screen resolution so we could initialize our log. Well, we're going to use those again to get the current, get some of the current information already being used by the stencil buffer, because it's at this point we're in a scenario where we need to copy some of the information that the old stencil buffer was using, but we do need to make a brand new one. We can't grab the current depth buffer that's being used by the graphics device, because after being initialized here in our constructor, as soon as we set that resolution of a preferred back buffer width and height, well, guess what's going to happen to our depth buffer?
It'll be that size.
It'll be set to that same size.
Right.
What we need here is we need a depth stencil buffer that is the same size as our new internal drawing resolution, which is fixed drawing width and height, which will match our
output size.
Exactly, our internal render target. So let's go ahead and put all of this together. Let's begin with the render target itself. So we'll address the draw buffer field. We'll set that equal to a new instance of render target 2D, and we're going to need to fill in a few things to get this render target created. First is we need to know exactly what graphics device is this rendered target going to be placed. So we will feed in here the game's graphics device. Now we need to specify the size of our render target. And again, this is the larger, well, in our case, larger resolution. I would guess we could say fixed resolution.
Yeah, because you can't really say it's going to be larger or smaller. That depends on what output they choose in the XML file.
Exactly, because nothing's preventing someone from setting a higher resolution in the output side of things. So we need to set up a render target here. We'll match our fixed drawing width and height. So we'll look into global state, and we'll grab fixed drawing width for our width parameter, and global state dot fixed drawing height for our height parameter. Now after this we have number of levels, and this just gets into multi-sampling, so we're only going to worry about one. Just like when we're creating textures by hand, we won't delve too deeply into creating more advanced multi-texturing.
Sure.
Now the final thing we need is the surface format, and we're going to follow the same format that our texture 2D is going to be in, and that is surface format dot color. So that takes care of the creation of the render target 2D. Now we can turn our attention to the depth buffer. So look at the draw depth buffer field, and we'll set that equal to a new instance of depth stencil buffer. Once again, we need to know what graphics device this is going to be placed on, so we'll feed in the graphics device currently referenced by the game. Now for the width and height, these need to match our render target, and we've already set those based on our fixed drawing width and height, so I'll simply copy those and put them in place. So again, the width parameter will be fixed drawing width, the height parameter will be fixed drawing height.
Easy enough.
Now, the last parameter that we need is the format for our depth buffer. And at this point, we're not so worried about setting that ourselves. It would be more convenient if we would just use the format currently in use by the graphics device. Now we have access to that depth format because we have up here a presentation parameters instance looking at those things. So that means we can look at presentation parameters dot auto depth buffer stencil format.
So in the end, we're kind of letting this this depth stencil buffer do whatever it needs to do. We're just making sure that we're creating one at the proper resolution.
Exactly. So with those two lines, we now have a render target set up and ready for use. Now before we turn our attention away from load content, I do want to make a change to the log, because currently the log is looking at our screen resolution, currently held in the presentation parameters, which means it's going to snap to the screen, not to the overall internal drawing buffer, which will be kind of an odd scenario since the log is going to be drawn to the internal one, not directly to the screen.
Right.
So we do want to make sure we want to jump in here and change these over to our fixed version. So instead of presentation parameters.backBufferHeight, we'll change this to global state dot fixed drawing height.
That makes sense.
And we'll change back buffer width to global state dot fixed drawing width.
And with that, we should be creating the log at the appropriate size for our internal screen, and that'll get output and just rescaled appropriately.
Exactly. So, moving on from here, now we need to put our target switching in place. What I mean by that is throughout the process of drawing to the render target and then turning around and drawing to the screen, we're going to be using our graphics device kind of like that imaginary projector on the whiteboard.
Yeah, actually, if we jump back over to the whiteboard, we can still see this. We imagined that projector actually being on a swiveling base, where it starts off at step 1 by projecting our texture onto our internal screen, our render buffer?
Our render target, yes.
Render target, thank you. And then once we've got that already in place, we then take a snapshot of it, and then we spin around, which leads us to step 2, where we actually project that out to the viewer.
So it's here in code that we actually need to address these steps. So what I'm going to do is I'll scroll down to the draw method, and we'll put a few methods right before draw itself. Now, inside of an XNA game, you're given 2 additional methods in addition to draw itself. You have begin draw and end draw. And these are methods that can be overridden inside of any game class.
Okay.
And the idea here is that the begin draw method gets called before draw, and the end draw gets called after draw.
Okay.
Simple enough. But we can leverage these to conveniently put some of our, we can almost be sneaky about the swivel base to where everything inside of draw doesn't care about this whole different camera focus solution we're starting to put together.
Sure.
Everything here can remain the same. We don't have to worry about Okay, as we're drawing text, are we worrying about the internal, the external? We don't have to worry about that. This will stay the same. What we're going to do is address begin draw and end draw. So right before we call draw, we'll change our focus and look at the render target.
Okay.
Then right after this draw call is run, we'll change our focus back to the output, meaning our back buffer, or you could just look at that as the screen itself.
Mm-hmm.
So we'll turn back to the screen, but as soon as we turn back to the screen, we'll actually take, because I mean, after we look at the screen, we still have the information in our render target.
Now, just to make sure everybody's clear, when you say we're looking at the screen, you mean like the output monitor, what the viewer sees?
Right.
Okay. So, just to make sure everybody's clear on terminology, we'll generally say the render target for the internal and output or screen for whatever the viewer's looking at.
Right.
Okay.
So let's jump in here and take care of the begin draw call. This is going to be an override to the protected method begin draw. Now we do have to be a little bit clever with this already existing base call, since this method begin draw actually has a return type. It's looking for a return of whether or not this draw call succeeded. What we're going to do is, instead of directly returning the call to base.draw, we're going to run this first. We want to make sure our call to begin draw, our base begin draw, happens before all of our code, but we still want to return properly if it came back false. If this method ever comes back false, it means the internal begin draw failed, so we'll dump out ourselves. So that means all we'll do here is we'll change this return to an if statement, and we'll say that if that draw failed, so if not base.begin draw, then something below us didn't work. So let's in turn return ourselves, and so immediately return false. And the reason we'll do this is to make sure that we don't end up drawing any of our own code. If this failed, then we will in turn not draw anything. Now if it did work, we will return true. So with a little bit of the return semantics taken care of, we can now address the actual graphics device. So it's at this point where, all right, begin draw. We need to get ready to start using our internal render target. And we'll do that by addressing the graphics device. And we can call set render target. And set render target is going to need to take in a render target index, which we're not going to worry about here because we're not going to be leveraging different render targets in this manner. So we'll just set that to 0. And then we will set up the actual render target to which we wish to render. And that is in existence in the form of draw buffer. So in this one line, we have now pointed our graphics device at the new render target. Now if we left things alone at this point, we would have a problem where our graphics device's depth buffer doesn't match the new size, because we're talking about a render target that has a different size than the output or the screen. So we need to make sure that we link up our appropriate draw depth buffer. So we'll do that by looking at the graphics device, and then we'll address depth stencil buffer, and we'll set that to be equal to the field draw depth buffer. So at this point we've now turned our graphics card's focus to the render target and associated it with a depth buffer of the appropriate size. And really that's it for begin draw. It's just a matter of turning our attention to the render target. Now we can look at end draw. So we'll make an override, and we'll be overriding end draw. And in this case, we will leave our call to base.endDraw just as is, but we'll move it down so that it happens after all of our own code. Now,
otherwise we wouldn't get anything drawn, would we?
It all depends on the order of other components that might be
right.
So, the very first thing we'll do is we'll grab the current presentation parameters for the graphics device, because we'll need that shortly when we go to draw something to the size of the screen. In order to draw to the size of the screen, we need to know the size of the screen. So we will make a presentation parameter. Actually, presentation parameters variable. We'll call that pp and set that equal to graphics device dot presentation parameters.
Okay.
Now we're going to make sure that we change our focus to the actual output, to the actual screen.
We're going to do this basically by saying that we don't need the render target and we don't need the stencil buffer right now, right?
Right. In a weird sort of sense, it's like simply telling the graphics device to look away from a render target means it'll default back to the output, the screen.
Gotcha. Well, it's got to output something.
So in order to do this, we'll look back at graphics device, and we will again run a set render target call. But for set render target, again, we're not worried about the index. And for the render target, we're just going to specify null. And this way we'll indicate no render target, so the graphics device will go back to using the back buffer, which in turn displays on the screen.
That's so cool that you don't have to actually tell it to look back at the back buffer anyway.
Yeah, that's just smart enough to know that's like, well, no render target, and then we look back at the screen. Now, we also need to make sure that we're not trying to tell it to use our depth buffer that is sized for the render target when it looks at the probably differently sized screen. So what we'll do is we'll look at our graphics device.depth stencil buffer, and we'll simply set that to null. So we're going to live dangerous a little bit with this depth buffer.
Okay.
The idea here is that since in order to redraw the internal screen, or excuse me, the internal render target onto the real output screen, we're not going to be doing a lot of complex drawing operations. We're not going to worry about clipping or things drawing on top of other things.
Right.
We have one graphic already drawn. All it needs to be done is sized and drawn to the output. So that means we don't really need a depth stencil buffer in order to accomplish this.
Okay.
So in order to save on overhead, we simply won't worry about one. We'll just set it to null. Now, in order to perform the actual operation of drawing, we're first going to assemble a rectangle that matches the size of our output screen. So we'll make a rectangle, and we'll call this destination rect, or DEST rect. And we'll make this a new rectangle. And for the rectangle dimensions, we'll give 0 in x, 0 in y, and then a width and height matching our screen. And that width and height can be gathered by looking at the presentation parameters back buffer depth. Because again, it's that back buffer that is really our main output. So that's going to stay the same as our screen resolution.
Right.
So our destination rectangle's width will be the back buffer width, and the height will be the back buffer height. So now I have a rectangle which we can draw any texture we want it into, because of course the sprite batch allows us to set a rectangle, a target rectangle. And so any rectangle we draw, or any texture we draw into this rectangle, will now occupy the entire screen. So what would happen if we looked at the render target and drew that to this rectangle? That's how we would actually accomplish scaling. Now before we jump into the draw, there are a few things we probably want to do. We can take our graphics device and make sure that we clear it before we begin drawing. So we'll make a call to clear, and we're actually going to use one of the overloads, since we do have to be a little bit careful because we're running in a scenario without depth stencil buffer. So we want to make sure that we're specific as to exactly what we're clearing. So in here we'll put clear options dot target. And then for our color, we'll clear to a color of black. And for a depth, we'll simply give a depth value of 1 and a stencil value of 0. So rather than use an actual depth stencil buffer, we'll just plug the values in ourselves, and then we won't need a depth stencil buffer.
Okay.
Now, on the drawing side of things, now we're actually ready to begin drawing. And we're going to reuse the exact same sprite batch that we use down here in Draw. We'll use that same sprite batch when drawing, because really we're talking about the same graphics device.
We're just drawing in a new location.
Exactly. But we need to make sure that we have a call to sprite batch.begin to get the sprite batch ready to begin receiving sprites. Then we can turn around and make the actual call to draw. So this is sprite batch.draw. So what do we use for our texture? We need a source texture to begin drawing.
What are we going to draw?
And well, in this case, we're actually going to draw the the render target. But in order to draw it, we need to look at that render target as a texture. Because if you remember, up here in its definition, that's a render target, not a texture 2D. Now, fortunately, the render target has some functionality built into it that will allow it to read its information back out in the form of a texture 2D.
Okay.
Meaning if we look at draw buffer, so we're looking at our render target here, we can run get texture. And that is going to return a texture 2D based on whatever the buffer contains.
Which means this really is like taking a picture of that internal screen.
Right, so if you want to look at that camera aspect of the conceptual drawing, this is our camera.
Mm-hmm.
We're using get texture to look at this draw buffer and return a texture 2D.
Yep, there's your snapshot. It just got developed. You now have a texture.
And now that we have a texture, we're free to draw it wherever we would like. And we would like to draw this texture to the coordinates specified by the destination rectangle. So we'll plug in destination rect. And finally, for the color, we don't need any additional color modulation. So color will be white. And that's it. That's the only thing that we're going to draw. So we can make our call to sprite batch dot end, get everything flushed out to the displayed device, and that should take care of it. That now has end draw in place. Now at this point, we should be able to run the game. So let's build, run, and look at that.
Woohoo!
We now have what it looks like is that background texture got smaller.
Yeah, it does.
Really what it is that original background texture was designed at 1280 by 960 in order to match the internal fixed resolution. So for a while we were drawing it to test the screen system, we were actually just drawing a section that was like this top left corner of the screen.
Right, which is why the word main looked like it was being cropped. Now it's being rendered out internally at its full resolution, and that final result is being scaled down as a 2D texture.
And you also notice one other artifact we're getting from the fact that we're drawing to a high internal resolution and then showing out at a scaled one is our log text now looks a lot smaller.
And that's actually going to be true of anything you design for a system like this, especially if your internal resolution for your render target is exceptionally large and you're going to often be scaling it down. Be careful of how far you scale things down. Try to think about your output resolutions beforehand, because what you don't want to have happen is to design things to be way too small. So you're creating your graphics, your sprites, your backgrounds, and all that, and maybe you have a bunch of vertical or horizontal lines that are 1 to 2 pixels. What's going to happen when you scale those? They're either going to be completely non-existent or they're going to kind of shimmer due to anti-aliasing. Either way, it won't be good. So try to take that size into account during your design process.
Right. Now, one last thing is you'll notice the text bottom right is now appears to have moved again. But at this point, we want to show that, yes, it has moved. That's because we went from the resolution of our small screen res over to the internal.
Right. We had originally positioned that bottom right piece of text based on our XML's actual resolution that it had pumped out, like, was 908 by some random number.
Right. So let's do a quick test. Let's recalibrate this positioning marker to 1280 by 960 and then play around with some screen resolutions. So very briefly, let's jump down here to our draw call where we're drawing out this bottom right text. And let's move this to the bottom right of our new 1280 by 960 screen. So we're actually going to position this at 1160
something by 9 something
by 930. Of course, we're drawing the text from the top left, so we have to take into account the size of the text itself.
Sure.
But that, if we run the game, should now position bottom right.
Very
Once
nice.
again, at the bottom right.
Now what happens if you change resolution?
All right, let's go back to the original problem, and now let's retest the whole system. What if, once again, we wanted to get to 800 by 600? What happens now? Well, we have slightly smaller text still drawn in the bottom right-hand corner of the screen.
Very nice.
So we could even do something crazy like jump all the way down to 320 by 240.
It'll probably be illegible at this point.
Oh yeah, that's pretty illegible.
Yeah.
Just a tiny little speck of yellow down in the corner.
If I didn't know in advance that said bottom right, I'd be just kind of guessing.
So with that, really, now we can see that, yes, we can indeed change screen resolutions all day long, and really all that happens is we get different sizes in the resulting drawn texture.
Right. Now, again, just to reiterate, that does sort of, that specifies that you're not going to want to make tremendous sweeping changes between your internal rendering system, your render target, and your final output. So do try to keep your final output in mind as you're setting the system up.
Exactly. Now, before we end everything off, I do want to set this resolution back to our original recording resolution of 908 by 681. Just to get this all back to the way it should be. And at this point, we can also take out the marker down here inside of our game.
Little bottom right marker.
At this point, we're done with the bottom right marker. It's served its purpose well, but now we have proven that screen draw scaling is working, so we don't need it anymore.
Anything else you want to add?
No, I think that really brings this video to a close. We've got draw scaling fully functional and in place.
Well, let's move on to the next video.